Hello there and welcome to this video. I'm going to be treating recursion. So as you can see on your screen here, recursion, a basic knowledge about recursion is a function calling itself. So as you can see here, it says recursion is the process of repeating items in a self-similar way. In programming language, a program allows you to call a function inside the same function. Then it is called a recursive call of the function. So as you can see right here, you can see the void recursion, and you can see the function name is recursion, and inside this function you can see we also have another function call which is the same function. So a function calling itself is a recursion. So now we're going to look at this example which is the factorial, the most common example, and you're going to do it in your project. You'll be asked to do this exact thing in your project. So you can see right so basically the idea about this recursion is whenever a recursion is done, it keep on stacking the outputs, keep on stacking it. Like, okay, let's say you have n, and once you call the recursion, the value of n is to keep on putting it in the stack and piling it all each other. If you want to learn more about stack, you can just Google search. It's just a type of memory that's the stack, and if the stack only the computer have access to the stack, and the if you have access, that's where the malloc, right, the malloc and the free, that's where they comes in. So now let's say this number factorial. You can see that's here. So this is factorial, and if you come down here, you can see we're calling this factorial again. So you know the idea behind factorial, which is if you have 4 factorial, then it's going to be 4 times 3 times 2 times 1, and you're going to answer to be, I think that will be, okay, that's 24. You get your answer to be 24. But if you're going to break this down, just the way programmers do, you break problems down and you start solving it step by step. You take one step at a time. If you break it down, you're going to see is when you say 4 factorial, then it's going to be 4 multiplied by the factorial of 3. So if you see it there, so the first thing you want to do when you write a recursive function is you want to think about the base case. The base case, like, okay, there's this near value in which the computer is going to look for, the program is going to look for in order to execute the load, because when you're dealing with recursion, it's more like a loop. It go back and do it over and over and over again. So now when we look at this, that's the base case over here. So it says if high, we already did this on sign in there, which means we want to deal with just positive values alone. You can make your assertion on signed. You can make your assertion that to know more about that. So it means we basically deal with positive integers here. So it says if high is less than equals to 1, return 1, which means when you get 1 factorial, then it's to return 1, and you know that 1 factorial equals to 1. So it says if high is less than or equals to 1, that means if it is 0, if it is minus 1, if it is minus 2, if it is minus 3 or minus 1000, 2000, 3000, then you're going to return 1. Includes 0 too. So if it's 0, you're going to return 1. So now else. So basically this is going to be here, right? Means else, or so if high is not equals to this, if I is greater than 1 or not equals to 1, then it's going to come down here and you're going to do this. So it's going to return high multiplied by the factorial of I minus 1. So it's going to stack this in the memory. Let's say the value of I is 4 right here. This is 4 right here. So it's going to stack this 4 in the memory. So you have 4 in the memory. then it's gonna go to the factorial of I minus 1, which is 4 minus 1 is gonna give you 3. Then it's gonna come over here, it's gonna check whether 3 is less than equals to. See, if this condition is not true, then it's gonna come back here. 4 is already in the memory, then it's gonna stack 3 in the memory again, then it's gonna come right down. It's gonna come down here and say, okay, 3 factorial of 3 minus 1, which is 2. Then it's gonna check this condition again. 2 is less than equals to 1, so this condition is not true. Then it's gonna stack 2 in the memory again, then it's gonna come down here and do 2 minus 1, and that's 1, and once again there, then it returns 1. So when factorial is equals to 1, then it's gonna start multiplying. Everything is stacked on the memory, so that will be 4 multiplied by 3 multiplied by 2 multiplied by 1, and you eventually get your answer. So that's how recursion works. It's gonna stack it in the memory, then it's gonna do it all over and all over again. So you can go look for other videos that give more explanation on this if you don't get this, or you can just go over the video again to understand better on this recursive function or recursion. Yeah, so that will be it for this video. In the next video, I'm going to walk you through the tasks in ALX, so that you can have a better understanding of what a recursion really is.